The seabed is the ocean's ultimate carbon sink, fed with organic matter through the entire biological pump. Globally, subtidal seabed sediments are estimated to store up to 3.1 teratons of organic carbon in their top 1 metre. This is over 11 teratons of CO2 equivalent, more than twice that of all terrestrial soils combined. This carbon is most concentrated in near-coast areas, particularly in muddier sediments, in upwelling zones and within fjords and estuaries. Much lower concentrations are found in deep basins and abyssal sediments, but due to their large area, these zones make up the dominant carbon store of the ocean. Global estimates of sequestration rates are in the range of around 130 to 350 million tonnes of organic carbon per year, which is equal to up to 1.3 gigatons of CO2 equivalent. This is an average of only 0.04 tonnes of CO2 per hectare per year. However, dependent on the environmental settings, local sequestration rates can reach up to and above 3.2 tonnes of CO2 per hectare per year. The sequestration of carbon in seabed sediments requires a healthy functioning ecosystem at a whole seascape scale. One way to promote carbon sequestration would be to increase primary production at the surface, such as through seaweed aquaculture, vegetated habitat restoration and improved water quality. We must also reduce our impact on the wider biological pump, striving for healthy, diverse invertebrate and zooplankton communities and maintaining fish and marine vertebrates at higher population sizes. However, due to the relatively low annual sequestration rates mentioned earlier, avoided emissions by the removal of disturbance from stored carbon far outweighs the climate mitigation potential of promoting sequestration. A recent global estimate calculated that bottom trawling and dredging may release between 0.6 to 1.5 gigatons of CO2 into the water column each year. This is a similar amount released into the atmosphere by global aviation each year. More evidence is urgently needed to more accurately quantify this impact of physical disturbance on seabed carbon and incorporate full, evidence-based carbon considerations into global seabed management. If handled correctly, blue carbon in seabed sediments could unlock major carbon financing opportunities and huge climate change mitigation potential. This should be done by implementing full protection of stocks, while allowing recovery and potentially restoration at the scale of whole seascapes, not small fragmented pockets.